In this example, the figure shows a capacitor of 5 microfarad connected to a 20 volt battery. Now, when a dielectric slab of constant K equal to 3 is inserted in the capacitor, we are required to find the work done by battery in supplying the excess charge to the capacitor. Here we can directly state, and we also studied in the previous sections, that when a dielectric is inserted into a capacitor, its capacitance increases, and to achieve a new steady state, battery has to supply some more charge to the capacitor, and in supplying excess charge, battery has to do some work. So in this situation, when the dielectric is inserted, its capacitance will change. Now in solution, we can first calculate the charge on capacitor initially in a steady state is this initial charge we can write as CV. We calculate capacitance is 5 microfarad and V is 20 volts, so 5 into 20, this will be 100 microcoulomb. That will be the charge on the capacitor. And after dielectric insertion, if we calculate the new capacitance, after dielectric insertion, capacitance will become C prime, which is Kc, we know. So this will be 5 multiplied by 3, it will be 15 microfarad. And final charge, if we calculate on capacitor after attaining new steady state. New steady state implies after insertion of dielectric, again a steady state is achieved. The final charge we can write as C prime V, as here C prime is 15 microfarad and V remains same as 20. So it will be 15 into 20, that is 300 microcoulomb charge. That is the final charge on capacitor. If we calculate the excess charge supplied by the battery, excess charge supplied by battery, this can be written as delta Q excess. That will be Q final minus Q initial. That will be, you can see 300 minus 100 is 200 microcoulomb. This is the amount of charge the battery has supplied, delta Q excess, during the process of insertion of dielectric between initial and final steady state. So we can directly calculate the work done by battery as W is the amount of charge which is flown through the battery multiplied by the battery potential difference. So this will be 200 microcoulomb multiplied by the battery voltage, that is 20 volt. So this will be, you can see 4000 microjoule, or it can be written as 4 millijoule. That will be the answer to this problem.